Hello everyone and welcome to this webinar on the software development kit of the Furhat platform. This is the third webinar in the series. We previously did one on the natural language understanding of the robot, as well as the computer vision system of the Furhat robot, and maybe computer vision in general as well. They are available on YouTube. We'll post a link to them in the chat. And I guess you will find it in the description of the video later when we publish this on YouTube as well. It's lovely to see such a mix of people joining us here today. We can see some new customers, some of our old customers, some senior developers, junior developers, people from academia and from the commercial side as well. So great to see such a nice mix of people here. This time, Furhat will not be joining us. Instead, we will get to meet the virtual Furhat, the twin of Furhat. I'm Nils Hagberg. I'm product owner for Furhat X, for the robot for research and early explorers. When I'm not product owner with Furhat, I like to go out longboarding with my longboard, and sometimes I fall, which explains this setup I have here with my arm. And today I will be giving you an overview and introduction to the Furhat platform and to the SDK. I'm joined today by Professor Gabriel Skantze, who sits opposite me here. Maybe you can say a few words about what you will be talking on a little later on.
Yes, so I'm a co-founder and chief scientist at Furhat Robotics, and I have worked a lot with developing the interaction and conversational framework for Furhat, and how you as a developer can develop skills or applications for Furhat using this framework. So that's what I'm going to be talking about a little bit later on in this.
Yes, great. But before we get into that segment, I would like to demonstrate to you the new SDK launcher application that we are releasing within a few days. You will be seeing now an early version of it that doesn't have the latest improvements to the user interface and the GUI of the app. That's what we are finalizing now. But the functionality will be same. But actually, before we get into that, I want to start off this session by putting it into some context. So let's start with an overview of the Furhat platform. What is the robot? What is the SDK? So let me bring up my screen and let's get started. All right, so the Furhat development platform and the Furhat Robot platform. It consists of at the base level the Furhat Robot. And the Furhat Robot consists of the physical hardware, the camera, the projector, motors, etc. And then the Furhat OS. And Furhat OS is our Linux-based operating system that runs on the Furhat Robot. On top of the Linux kernel, it runs a number of core services responsible for things like speech synthesis, speech recognition, computer vision, motor servos, the 3D animation, etc. On top of that is the Furhat SDK, which is a collection of tools that enables and helps you to develop applications for the Furhat robot. And these applications, we call them skills, and you develop them on your own computer then in the developer environment. As I said, the SDK is a set of tools, and the primary tool is the dialogue framework, or perhaps skill framework would be a better term for it. And this is where you program your interaction, essentially the programming language for the robot. And then on the top here we have the skills, the skill. And skills are applications that run on Furhat Robot. And when we say skills, we mean the skill in terms of the whole interaction. For example, a barista skill or a language teacher skill. If you're familiar with voice assistants, they also use the term skill, but perhaps in a more narrow way, like take order skill or practice practice words skill. To give you an example of this framework or this of this the Furhat platform, if you use the example of computer vision, so in the Furhat Robot, then of course the camera will capture the users standing in front of the robot, and on the OS layer, the computer vision will detect the faces. In the SDK layer, this information from the computer vision is mapped into the situation model, and this is exposed in the dialogue framework to the SDK to the skill developer, so that in your skill you create the behavior of the robot. So let's talk a little bit about the skill developer and what competencies are needed to work with the Furhat platform to create skills. To create skills, we say that mainly 3 competences are required. They can be all in one person if you're a very lucky and if you have a very talented person, or it's a small team. And of course, this will depend on specifically what kind of interaction you are building. If it's a more complex one in terms of dialogue and user management, or if it's a more simple one in dialogue and user management, but maybe more complex on the technical aspects of doing integrations with other systems and so on. But basically, you need some kind of content creator that can combine domain knowledge with user needs, the physical space, and an understanding of how social interaction can add value. An interaction designer with strong writing skills to create good dialogue that flows and is natural, and also with a good sense for physical environments, because the robot is a situated robot. The physical environment play a big role or a huge importance in the interaction. If you place a robot in the entrance, people will behave differently than if you place the robot in the back of a room, for example. And then maybe the core focus of this session, the developer. We say some kind of a creative developer with some experience of conversational technologies. Again, the more technical your skill is with integration with backend systems and talking with databases and so on, the better it is to have a strong, well-experienced developer. If you can stay within the Furhat universe and just work in a dialogue framework and use the tools and functions that we have with the robot, then I would say it's more important that you have a good understanding of human dialogue and how to create a good system for managing a conversation and an interaction with users. If you have some experience with Kotlin, which is the programming language that you will be using, that's a big plus. It's not a requirement. I myself did not know Kotlin before I started here. I had just some limited experience with Java and other object-oriented program language like Python, like one university course, like that's it. And I'm totally able to learn on the job and figure out what needs to be done to create good interactions. All right. So I mentioned that the SDK is a suite of tools, and here I just want to show you the tools that are available. We'll go through them a little bit. We'll show the examples of them a little bit later, but starting here in the top left, this is the new launcher application that we are giving out to the world in a few days. And from here, you will start the SDK and you can access the web interface. You can run skills. In coming releases, we hope to add more and more things to this application so you can stay within this one app and don't have to go through different tools that are available on different places. So this is the first version. We hope to expand on it as we move forward. The second box here is the web interface of the robot, where you can monitor interactions and simulate users in the interaction. On the third one here is the virtual robot head to use to simulate the physical robot, of course. In the bottom left here is the dialogue framework that is built in Kotlin. This Gabriel will go a little more into depth about that. The docs page is something that's crucial to develop skills, and I would say we put a lot of effort into creating a good documentation here, and especially in the getting started introduction parts. We won't be able to go through the tutorial sort of from start to finish in this webinar, but I highly encourage people to check that out and to spend some time with the docs. Another tool I will be showing a little bit later today, or a little bit later in the session, is the visual programming tool based on Scratch that's called Blockly. That can be used for doing quick prototypes. I think it's also a good tool to get acquainted with the dialogue framework and how you build skills, because it's basically a mirror of the dialogue framework that you have access to in Kotlin. And then finally, we have a log viewer tool and a lip syncing tool to create lip sync files if you're using pre-recorded speech. All right, so I would like to now run the launcher with you here today, show you how that works. Let me show put up my screen here. You can download you will be able to download the launcher from Furhat.io. Right now we have the SDK as a binary zip file that you can download, but in a few days you will be able to download the launcher skill and install the SDK from there. So let me actually share my screen again, and we'll run the launcher. There we are. I hope you can see my screen right now. Let me run the launcher here that I've downloaded. I'm running it on Mac. This is of course available for also for Windows and Unix. Can start it. It will ask me here for open an online. When the first time you run the SDK, you need to provide an API token. And when you have accessed the SDK, you have downloaded from Furhat.io, and in that Furhat.io, you will have then an account, and in that account you can find this token. Let me. I have a little bit too many windows here, and let's move this one. Here in the Furhat developer zone, in my account settings. Oops, I was not logged in, so let me log in first. In settings, if I scroll down here, I have my API token. Copy that one. Let me enter it here. And now you can see I'm logged in with my user account. And this is you only need to do this once when you install the launcher the first time. Let's click here to install. This will also install the Java Development Kit 8 that is required to run the SDK. But this is now bundled together with the SDK, so you wouldn't have to download and install that separately. And we hope to have eliminated some issues that some people were having with the versions of Java and so on. While this is installing, let me show you what else you can find in the developer zone. So we have the docs page. We have some example skills on GitHub. And actually I want to show you there. We just uploaded a new one that can be interesting for some people. It's actually not in the list of example skills. So if I click back one directory here, we have this one, the camera feed demo. So this is a coding example of how you can pipe the audio stream from the robot, from the physical robot, and use that video stream to whatever you would like to do with it. And this is a feature that's available for our research robot out there. For commercial robots, we think that privacy could be an issue here. So before we open that feature up to you, we would like to have a conversation on what you're planning to do with that camera feed. And then we have support channel to create tickets. And in the tools here, we have the lip syncing tool and the log viewer. Let's just take a quick view of the log viewer. You can read more about the details of it in the docs, but here I have access to my logs of interactions. This was a very short interaction. And this can be both from my, that I have run on a robot, or the one I've been running on my local machine. I think perhaps it's finished installing. Let's go. Yes, so it's finished installed. So let's launch the SDK. Now the SDK is running, and when it's running, we should also get the virtual Furhat head popping up. Here we go. A little bit small, maybe we can make it a little bit bigger. And we'll put you down here in the corner. So the first thing I would like to show you here is let's go to the web interface and open that one and see the SDK and test out the SDK. Unfortunately, it opened here in another window, so let me bring down the window here. So I have two screens here. There we go, right? So the web interface mimics the web interface that you have with the real robot. So it's essentially the same. There are a couple of things that are different, and I will point them out one by one. For starters, we don't have a camera feed here in the beginning, way that you would have if you would access the robot and the web interface from the robot. So the SDK is not using any camera feed from your laptop. Instead, you will need to simulate any activities that is coming from the camera by placing virtual users around. I'll show that in the dashboard. But before I show you that, I will also point out that in the virtual Furhat here, we only have access to one of the mask models, what's typically called adult, but in this case here it's called Bertil. So if you have additional masks with the robot, currently in the virtual Furhat, we only have this adult mask, the standard one implemented. There's a couple of textures available here. If you have the physical robot, you will actually have more textures. I think it's 21 textures at the moment. These are the most common one and that we've been having for some time. Hopefully we will keep adding the other textures to the SDK as well. And for voices, in the SDK, you only have access to the voices from Amazon Polly. If you have a research robot, you will also have, in the robot, you will also have access to onboard voice packages from Acapella and from Cereproc. But because these are onboard voice packages and they're also a license agreement that we have with those providers, that prohibits us to include this in the SDK. But that can be good for you to know. And then we can, similar to the real robot, we can try out that everything is, it can do everything it can do. We can move around the head by moving around the purple dot here. We can test the
Hallo daar, ik ben een sociaal intelligente robot.
I'm not sure you can actually hear what the robot is saying here, but we can test the speech recognizer. Hey, can you hear what I'm saying? So everything seems to be working fine. Generally, I think testing the speech recognizer is a good test. If that one works, typically SDK is running like it should. If there's an issue here, you know, check your microphone, check your internet connection. All right, so moving on to the dashboard. I mentioned that because there is no camera feed in the SDK, you would have to simulate any user, and you do that by double-clicking in front of the robot. We can add multiple users, double-clicking again, we remove them. We can also simulate their attention by dragging in this view. And we can, of course, move them around in the space by having them entering the interaction space and so on. And on the right side here, we get the transcript of the dialogue with the person. And a good tip here is to tick this show intent box that will give some extra information in the dialogue. You also have a wizard tab here if you have if you're running a wizard set up with lots of buttons. All right, let me hide this window for a little bit and go back to the SDK. So let's actually run a skill. And we can now run a skill by pressing the Start Skill button here. And I have compiled skill files that I have done previously. So let's test the language teacher. Let's start that one. And we can see here in the web interface when the skill has started running. It should say here, running skill.
Guten Tag. Hello. Welcome to your first German lesson. I am Furhat. Or should I say, Ich bin Furhat. So, should we get started with the lesson?
No, I'm busy.
Come on. You'll do great. Did you know that English, being a Germanic language, has a lot of similarities?
When you're running the SDK and when you're running a skill, there's the option here to view the console, where you can see if there are any error messages that's being sent out from the skill or from the SDK. There's also the skill can also output error messages here in the console. All right. The next step I would like to show you is how to create your first skill. And I hope we will be adding a button here soon so we can just create a skill by pressing a button. In this first version, you will have to do this a little more manually. So I will open a terminal. And let me go to the directory of the SDK that we just installed with the launcher, and that one will be located in your user folder and in the .furhat in a hidden catalog. So launcher, SDK, and the version. And from here, we can use the command Gradle W. I'm actually gonna copy paste the command here so I'm not making any writing mistakes. This is of course, the instruction to do this is of course available in the docs. So here we can run the command to create skill. We have named the project Getting Started, and we put this one in a folder somewhere where we're able to find it. So this will take a minute. And now we can go to our IDE. We recommend using IntelliJ IDE, where you can program your interaction. It's possible to use other ones, and we have customers using other ones. We think IntelliJ works really well with Kotlin and with SDK, so we encourage everyone to use it. And you can use the community edition. That's fine. You don't need to have the paid version. So we will import a project, and we need to find the Getting Started. Also, that's one. I put it in workspace fields, maybe. No, sorry, workspace. Here it is, right? Getting Started. and I will pick this build.gradle file. I think I can actually choose the whole catalog, but my experience is IntelliJ prefers you to select the build file, and it will have all the information to import the project into IntelliJ. So let's give it a minute for it to import it and build the project. And then we can, from within IntelliJ, we can run the skill. And the neat thing about this is that we can also, from in IntelliJ, we can run the skill on a robot. So we can, from IntelliJ, both run it on our local machine, and we can also try it on a robot. And I'll show that in a second. So now the project is configured. We have our source files here on the left. Again, the documentation will explain about this, especially the getting started guide will go through this from A to Z. And here we can see we have the main interaction state here for the skill, where they will start the interaction by asking, "Hi there, do you like robots?" And there's two behaviors defined here for people saying yes and for replies to no. Let's actually run this skill on the local machine. So we'll select the main function here, and we can run that one. And if we go back to the web interface of the robot, we should be able to see that a skill is running once it's get up and running. I think it's still compiling and building the project. Exactly. So the first time it will take a little extra time once you've done this.
Hi there.
Once.
Do you like robots?
Yes, of course.
I like humans.
So we can run it on on our local machine like this and test it and play around with it. I'm gonna stop it here. If I would like to run this on a robot, I can simply edit the run configurations, and I can add an option to the Java virtual machine. That would look something like this. And you would enter your IP address of the robot. We can click run, and we can run exactly the same interaction, but on a physical robot. I don't have a physical robot with me today, so I will skip to show that. Great. So that was an intro to the desktop launcher, and so that was a great intro to the desktop launcher and starting your first skill and creating your first skill and importing it in IntelliJ and starting working on in IntelliJ. I think now is a good time to hand it over to Gabriel, and he can talk a little bit more about that process of creating skills in the dialog framework that you would have access to in Kotlin.
Yes.
I need to mute myself, excuse me. I have to find the correct window.
Okay, great. Still some echo. Now we are good. So let's move on to the next part. So I'm gonna be talking about how to actually program interactions using Kotlin within IntelliJ that Nils mentioned up here. So let's start just by saying why some people wonder why we are using Kotlin. Kotlin, and maybe what is Kotlin? So Kotlin is a programming language that is based on the Java platform. So it runs on the Java virtual machine and it compiles into Java bytecode. And it means that it's completely interoperable with Java. So if you have any libraries in Java, you can use them directly in Kotlin. And vice versa, the thing you do in Kotlin can be used in Java and so on. So you can actually mix these two languages very easily, or other languages built on top of the Java virtual machine. It's developed by JetBrains since 2011, and you might know that JetBrains is the same company that develops IntelliJ that we use. That's why they sort of integrate so nicely. We are not the only one who like Kotlin. It's actually the preferred language for Android app developers, according to Google, since May 2019. There are some nice features about the language that we like, that you might like also. It's statically typed. You have very good type inference and ability to add extension functions. These are just some of the things. If you don't know what these things are, it doesn't really matter. But we think it's a really powerful language for these kind of applications. It has very nice support for what's called domain-specific languages, or DSL, which means that basically you can define, in a way, your own programming language within Kotlin, which we will see because we use it to define the dialog flow, the state charts, how when you define gestures for Furhat or define utterances and so on. We have sort of these little domain-specific languages for this. If you don't want to use Kotlin, we do have support for other programming languages. It's more limited, so it's more a matter of if you want to control the robot by asking it to say something, for example, or make a gesture and so on, and you want to develop the interaction using your own whatever framework you have. You can do that with what we call the robot remote control, or the RRC. It's based on Swagger, which means that it actually can build programming APIs for a ton of different languages, including, for example, Python or C, etc. If you're more, I'm not going to talk more about that. So if you're interested in that, please contact Nils at FurhatRobotics.com, and we can give you access to this. It's kind of a beta feature. Okay, so let's say you want to build an interaction, and let's say you want to build a robot that sells fruits. This is the reason we have this example, is that it's on our tutorial, so you can find it there, and it will guide you step by step how to actually build this application. But I'm going to use it as an example here as well. So let's say that we have our robot selling fruits, and we see the example here. The user is approaching. The robot says, "Hi there." The user say, "Hello." The robot says, "How about some fruits? What do you have?" We have banana, apple, orange, and cherry moya. "I would like 2 bananas and 3 apples." 2 bananas and 3 apples. What a lovely choice. Anything else? "Well, I changed my mind. I don't want the bananas." "Okay, let's remove that. Your current order is 3 apples. Anything else?" "No, thanks." "Okay, here is your order of 3 apples. Have a great day." So that's what an interaction might look like. It's sort of a very simple interaction, but it's good for example purposes. So how do you go about creating this interaction? So actually, whatever application you are developing, I would recommend you to start by writing an example interaction like this. This is how you imagine a user would interact with your system. And once you have done that, you can, as a next step, figure out what are the different states. So we are using a mechanism called state charts. It's similar to sort of a state machine or a flow chart, but it's more complex and powerful, and doesn't have the limitations that a very sort of simple state machine have. And we can see here that, okay, first the robot is idle, and then when the user start interaction, we have some kind of start state. We have a taking order state to take the initial order, and then we are in an anything else state where we try to see if the user wants something more or want to remove some fruit and so on, until we sort of are done. And you can see I've sort of sketched this state machine to the right here. So you can see that we have the states idle, start, taking order, anything else. We can be here in anything else until the user doesn't want anything else and is happy, and we go back to idle. So what is actually triggering these transitions then between these states? Well, it's different types of events basically, and often in the interaction, of course, if it's a conversation, the typical kind of event that triggers a transition is that the user says something, and what we do is that we say that the user, when the user says something, we want to map what the user is saying to an intent that is sort of a label on that utterance, what the user wants to do. But there are other types of events. So here, for example, we have something called onUserEnter, which means that the user is standing in front of the robot, which triggers then the transition here from idle to start. And then the robot said hello, and the user doing a greeting, which is saying hello or hi there or nice to see you, would trigger the transition to the next state, which is the taking order state. And the user buying fruit, there can be other things happening here, of course, so this is just extremely simple. The user might buy a fruit, and we are in the anything else, and here we might buy fruit or remove fruit until the user doesn't want anything else. So the no answer here would trigger a transition to idle again. However, in this very sort of simple way that you see here, there is sort of a limitation. What if the user, for example, leaves in the middle of the interaction? What should the robot do? If we had just a regular flow chart like this, or state machine like this, we would have to define for every state what happens if the user leaves, and we would have to put some kind of transition from that state to idle, for example. Or what if the user says, what did you say? Do you have to define that in every state? What should happen? That wouldn't sort of scale in any way. So what a state chart does is that you can define these states hierarchically, and you can extend other states basically. It's much like when you extend a class in object-oriented programming. So we define a general state called interaction that the other states are inheriting here. And here you find, for example, request repeat, which is like, what did you say? And regardless of which state we are in, we would sort of inherit this intent. So that's very nice. So anything else inherits the function of taking order, but it also adds the functionality of saying remove fruit, which doesn't make sense in the first initial taking order state. And also we have a no trigger here and a no trigger here, because the behavior of no, sort of the consequence of no, the implementation of no is quite different in anything else than in the taking order. Okay, so how do you define this? Once we have reached this point, how do you actually implement it in Kotlin? And here's where this domain-specific language that I was talking about comes into play. So you define a state here like idle state with this construct. So you say this is a state, and then you have these triggers. So the on entry, when we go to the idle state, we want Furhat to attend nobody, but then we have this trigger on user enter, which says that Furhat should attend it, which is the user that entered, and go to start. And in the start state, here we say that the start state extends the interaction state in this hierarchy. We say that on the entry, Furhat would say ask hi there. And the reason we say ask here is that because Furhat doesn't just say hi there, it actually starts to listen for a response from the user. That's what ask does. And then when we get the response of greeting, we go to the taking order state. So that's typically sort of what a state looks like. In most interaction states, through the interaction, you would have this kind of mechanism. You have the on entry, where Furhat would ask something, and then different response handlers for what the user might say, yes or no here. And you can also have a general response handler with no intent, which is what would be triggered if the user says something else than yes or no. And here we can do a re-entry, and typically you would trigger this on entry again, but if we have an on re-entry, you would say this, do you like robots, yes or no? We want to be more explicit here, so the user really says yes or no. And we have an on no response, which is if the user doesn't say anything, and then we just do a re-entry. So you define the state, and you have a couple of triggers here. These are just some of the triggers that are available. There are a lot of different types of triggers that you can read about in the documentation. We have, for example, also timer triggers. So after 5 seconds, you want one entering the state, or every second you want something to happen, and so on. So there are a lot of different types of triggers that you can add to your state, not just based on what the users say. I'm not going to talk so much about these intents, the natural language understanding part of Furhat, because we have a separate webinar that you can listen to for that. Just mentioning that we do have a lot of built-in intents for common things like yes, no, no, and don't know, maybe, greeting, goodbye, thanks, and so on. And also entities, which are sort of semantic pieces of information in the utterance. Common things like time, date, number, ordinal, color, and so on. But you can define this yourself, like the buy fruit. And again, I'm not going to go into the details here, but what you do is that you define examples. So if the user wants to buy a fruit, you would say that you could say, for example, yes, banana. You could say, I want an apple, or I would like some oranges. So these are just examples. And then the system uses this to recognize new utterances which are similar to these, like I would like an apple. But even if it doesn't match, that doesn't have to match exactly, of course. So what makes Furhat, of course, different from, for example, a smart speaker is that you handle users. You're more aware of who is actually there in front of the Furhat, and there might also be several users in front of Furhat. And that's what Nils showed you in the dashboard, where you can actually, if you don't have an actual Furhat with actual people standing there, you can insert virtual users in front of Furhat to see how and test your skill that way. And then to do this, we have something called an engagement policy, which is how Furhat should, when should Furhat consider someone to be someone to interact with. If someone is just standing far away in the background, that person might not want to interact with Furhat. So we shouldn't start interacting with them or consider them as a potential user. And for Furhat to know who is possible to interact with, we need what we call an engagement policy. And there is a built-in one that you use without you having to define anything, called a simple engagement policy. And that means that you have an inner interaction zone that you can see here in the dashboard, and an outer interaction zone that you can see. And when the user enters the inner interaction zone, that would make that user being part of the interaction, being engaged, so to speak. And then that would trigger this on user enter trigger that we talked about before. And when a user leaves the outer zone, we trigger an on user leave. And this creates a buffer, this inner and outer zone, which means that we will not have a user standing on the border constantly trigger an in and out event here. We can also define a max number of users. The default is 2 users. That is the maximum number. Even if more users enters the space, Furhat will simply ignore these users. You can define your own engagement policy, or just set the parameters of this simple engagement policy by defining the distance here in meters and the maximum numbers of users that you might want to allow for. So in your code, then you can access your users by these different collections. So you can say users list, which will give you a list of all engaged users, users.all, which is actually all the users, including the ones who are not engaged, like the person standing over here. Typically, you don't want to do that, but there might be very special cases where you would like to do that. And you can access the current user, which is the one that Furhat is now attending to. That is the current user. A random user, which gives you a random engaged user. So that would be someone of these. Users.other, which is a random engaged user, which is not the current user. So in this case, this would be this person here. You can also retrieve users in triggers. For example, in an on response, you might want to know who was the one responding. If I ask asking a question, it could be anyone answering here. But if you really want to know who said that, you can retrieve that through this it parameter, which is a thing in Kotlin that is passed to this trigger that contains information about this on-response event. And the it.userid gives you the user ID of that user, and then you, from this collection, you can retrieve that user, the user who responded. In the onUserEnter, the it actually is the user that entered, so you can get it directly this way. A nice thing in Kotlin is something called extension functions that I mentioned. And this is very nice for different purposes. One of the things that you can do is that you can add properties to users that you can store user data. So for example, we are playing a game, you might want to keep track of the user score. And then you just can, by this definition, we define a new property of users, which is the score, and we give it a default value of 0. And through the type inference, Kotlin understands that, okay, score is an integer. And played is a Boolean, so we can track whether the user has played this game before or not. And the default value is false, so this is a Boolean then. And it means that in your code, you can do things like users.current.score ++, which means that we increase the score of the current user. Or you can use the Boolean like if users current played, has the user current user played this before, for example. This is very powerful that you can store data in different users, user objects, and keep track of them. You can imagine the fruit seller, for example, keeping track of this user having ordered these fruits, or that user having ordered these other fruits. Of course, you might want to control Furhat's attention, where Furhat is looking. It's not just about where it's looking, actually, but if you attend a user like this, Furhat.attend, and then you have a user, then it could be users.current, for example, the current user. But typically you don't want to attend that. But users.other, you want to attend the other user. This actually does not only make Furhat look at that person and keep looking at that person, but it also sets that user as the now current user. So it shifts the current user. You can attend nobody, Furhat just looking down. You can attend everybody, Furhat will, of all the engaged users, Furhat will look around with a gaze. You can attend a specific location in space. You give the coordinates in space in X, Y, Z. And in this case, for example, Furhat will look like this. Or you can glance somewhere, location and the user. Glancing means that we don't set this as the current user. We just temporarily, for a short time, look in that direction and then look back again. We can detect user attention. So sense user attend is an event that you can have as a trigger, which means that some user's attention shifted. And we can check who that user was and whether the user is now attending Furhat or not. So that's typically what you do. You shift between attending Furhat and not attending Furhat. This can be used in other triggers, like in an on response we might want to use if the user who responded is attending Furhat, for example, or maybe they was talking to someone else. You can also make use of that. You can make gestures, of course. We have a gesture library, so you do Furhat.gesture, and here's, for example, a big smile under express disgust. You can also add parameters like the duration of the gesture or the strength of the gesture. But you can also define your own gestures with sort of a more sort of low-level parameters. It's all described in the documentation. A relatively new feature is that we can detect gestures from the user. For now, it's only smile, but it's a very nice feature. So this little piece of code, for example, on user gesture smile, Furhat gesture big smile, would make Furhat smile every time the user smiles, for example. So that's an interesting feature. Or if you have a robot telling jokes, you might want to know whether the user is laughing at the jokes or not. So you can come up with these interesting use cases. Also, from speech generation, we have seen that you can do Furhat say or Furhat ask and provide a string, and it will synthesize this string. But sometimes, since this is the multimodal experience, we want to add other things happening within that utterance. So you can actually mix text that is to be spoken with other kind of events in that text. And that's what we call an utterance is that kind of multimodal expression. So here, for example, we have Furhat say, and then we add items to this utterance. So we can say, hi there, and then at that point in time in the utterance, you want to do a smile, for example, and then say, nice to meet you. You can pick up your order, and we want to glance at the location and say, over there. So you synchronize all this in a very nice way. These utterances can be stored in a variable here. So we have this greeting where we store this smile and say hi there. And then we can say Furhat.say greeting, for example. And even more, you can define it as a function where you provide parameters. So here is a tell price, and that would make Furhat say it costs dollars. So if I say Furhat say tell price 500, Furhat would say it costs $500. So that's also extremely powerful that you can create these kind of constructs. Finally, from my side, just mentioning Wizard of Oz, and Nils briefly mentioned the support in the dashboard. And Wizard of Oz basically means that you can have an operator controlling the robot from another room or in the same room, depending on whether you want the user to know that there is an actual operator controlling the robot. And you can, this is a very powerful feature in Furhat SDK, because you can actually, you use the same framework you do for developing skills to create wizarded experiences. So we use the same kind of states and so on. It's just that we have this on button trigger. So when in a state where we have an on button greeting, for example, if we are in that state, this button would appear here automatically in the dashboard. And if we extend this wizard state, all the buttons in the wizard state will also appear here, like the smile and attend other user. And once we go to a new state, like the ask name, it would simply automatically switch the buttons that appear here. So you can create a very sort of interactive experience using Wizarded, where you don't just have a fixed set of buttons. And also you can combine it with other. You might want to add automatic behavior. So when someone enters Furhat, look at them, and that part you can automate, but have certain parts sort of controlled from the wizard. So this mix is actually extremely powerful and nice, and a good feature if you want to, for example, develop a new skill and want to see how do users react, what do they say to Furhat, which is hard to know beforehand before you have actually tried it with users. And then you can log the interactions and develop your skills and define your intents. So that was all from me. Over to Nils.
Use my other microphone. This maybe sounds better. I think this one was I was using before. I'll skip the Blockly demo. I have a lot of videos already on YouTube, so I'll send that in an email and you can check those out. I recommend it because it's a pretty neat tool. So let's jump into the questions. And maybe Gabriel, you can come join me here, and I'll adjust my camera a little bit so we can see you both. So the first question we got here was, doesn't the tool of storing user data create potential problems with GDPR? You want to address that, Gabriel?
Yes, so yeah, the way we store data here in this example is only for sort of Furhat short-term memory. So we're only storing this data during an interaction. So you can, of course, save this to disk and so on, but it's not trivial because we have no way of currently of sort of recognizing that it's the same user coming back. So they would have to provide a name and so on. That's functional. It's not there.
And the general design is that the robot will not automatically store any data from the face or any other data unless the developer specifically sets the skill to store these kind of things. So another question we had is, what are the practical max limits for the inner limit in the interaction space?
In terms of distance, or
I can imagine.
Or you mean number of users?
Yes, what's the practical limit of number of users?
Yeah, I think I don't know how many faces, it's like 10 or something that the camera can recognize. So that would sort of be, but I would imagine it very hard to fit 10 users in front of Furhat and have a meaningful conversation.
Yeah.
So I think practically, typically we allow for 2 or maybe max 3 users. And more than that is practically very hard to
yeah, and it is just hard to create an interaction where a robot can cater to all those sort of 3 people. It's a very, 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 very complex interaction. And I think practically how many people you can fit is, like we say, like around 2 or 3 people. If they're at a normal interaction distance from the robot. If there are more people than that, maybe you need to treating them as one audience rather than individual people.
Exactly. And you can do this attend all, and Furhat will look around at everyone, of course, if you don't care about sort of exactly who said what and so on.
Another question we have here is users attending elsewhere. Can we define virtual objects in the environment that the robot can attend to? Or does it only can attend to users and virtual users?
No, you can very well do that. So, for example, when we have a application where we have a screen, for example, we have the card game, for example. When you move a card on the screen, you want Furhat to follow the card with a gaze. And you can very well do that. But then you would use the attend location function. And you would have to do this, of course, repeatedly. So when the object moves, you would say, you attend a new location every time. So that's different from attending a user, because once you attend a user, Furhat will automatically follow that user since Furhat knows where the user is. But there is no sort of concept of objects currently in the SDK. So you would have to yourself call Furhat attend location repeatedly.
Yeah, and I guess if you are using the newly released feature of exposing the camera stream, you could potentially do some object recognition somewhere else and then communicate that with the robot, so the robot can then do some kind of object tracking.
We have seen such demos. It looks very nice, actually.
So I think we are already out of time. There are a couple of other questions. I'll make sure to answer them individually. Before I leave you today, I would like to just mention, if you don't have access to the SDK today already, go to furhat.io where you can request it, and the email will come in my inbox and I can send it out to you. And as I mentioned, in a couple of days we will have the new launcher ready, and we highly encourage everyone to move to the launcher, as it's a more we have some bugs that we have fixed, and it's a better installation process and so on, and we will be keeping adding more features to it, so we hope everyone will switch to that one. I would also like to mention today we talked only about the SDK and the virtual Furhat. If you are interested to see a demo of the real robot, or if you have a colleague or friend that you'd like to introduce, we are actually running like open sessions. We have one tomorrow. So if you're interested, send me an email and I'll share an invite to that open session. And the last thing I want to plug is the next webinar that we hopefully will have on the art of creating skills. So I'll invite an interaction designer and they can talk about the art really of creating skills and creating interactions. Oh, and also check out our blog. There I have some nice content around there if you don't want to wait for the next episode. The blog is available on our website. Great. Thank you all so much for joining us today. Stay safe. Don't forget to smile, and we'll see you in the next one.
Bye-bye.